Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning. So today we will continue with chapter 2, and before that I really hope that you already covered the chapter 1 that previously I upload in YouTube. Okay, for this week I will cover chapter 2. I think for chapter 2 I will cover for approximately in 3 sessions. For that we will have 3 weeks to cover chapter 2, because chapter 2 is we focus on more on latex concentrate processing technique, and because of that we will cover a different technique that being commonly used in industry. So we'll go through. So let's go and see what we will cover for this chapter. Okay, what is latex concentrate? Latex concentrate production in Malaysia is about 25% of total natural rubber production, and the export accounts for about 12.4%. So, in latex industry, Malaysia produce approximately 25%, and about, and for the export is approximately half of the total amounts of the latex concentrate productions. So this number actually a good number for Malaysia. That's although that Malaysia is not a number one latex producer currently, but but we still one of the best in latex concentrate production and research area. So this is an equal proportion of being consumed by local latex-based industry, particularly glove manufacturers. And the latex concentrate count for about 62.4% of the natural rubber consumption of the country. And the increase of consumption of latex concentrate in the local market has given rise to interest in a technical know-how of latex concentrate production and the quality control measures of latex production. So I will go through. One is just some introduction and briefing about the latex concentration. So we will cover more on the manufacturing methods and so on after this. Okay, latex must be exported as concentrate. I think, okay, the necessity of latex concentration, this is very important. I think I did cover this in some of the tests, final exams, maybe some quizzes. You can go to YouFuture and see the quizzes and crossword puzzle that have been made for you. Maybe after we finish cover this chapter 2. Okay, the importance of latex concentrate. The first one is it is uneconomical to transport preserved field latex over a large distance, because field latex contain 60% of serums or water, and over long distance actually you only transport 35% the RC durable contents of the latex. So it is wise to concentrate your latex approximately at least 60% of the RC before doing a transportation, and then you get more uniform properties of latex because of higher the properties of latex depends on the depends on the quality of the RC itself. So the higher percentage of the RC will reflects the better uniformities of latex properties as compared to the field latex, which is the 60% of serum will, what we call that, more fluctuated properties. So it is wise to produce latex concentrated for more uniform properties. The third one is economic advantage of manufacturing process, and require the raw latex to have the RC of 60%, which is the minimum. Okay. In terms of production, so the process. Okay, actually, for example, I take examples of manufacturing of latex good. For example, the latex glove. Okay, in order to have a certain thickness of latex latex glove, you may dip your former in a free latex multiple times so that you can have a certain thickness, because every every cycle that you dip in latex field, it will pick up a thin layers of DRC, because of the DRC of free latex is approximately 35%. But as compared to the concentrated latex, which is the 60% of DRC, every time you dip, you pick up more DRC or more latex on the former, so that in order to achieve a certain thickness that you want, you only require maybe less number of dipping process as compared to free latex process. So this is the reason why process of manufacturing require at least 60%. Other than that, okay, this is also related to the economic advantage in terms of the storage, the number 4, okay, reduce storage space. Okay, for example, if you receive 1 ton of latex, free latex, so you actually only have 35% of the RC, okay, but as compared to concentrated latex, you have 1 tons of concentrated latex, the percentage of the RC actually is 60% of the total amount. So in terms of the manufacturing, so you can produce more latex with smaller storage space. This is the reason why you need to produce a latex concentrated in terms of economic advantage of processing and storage stuff. So the 2.2, the methods of concentration. Okay, this is the heart of this I will say this code, which is latex concentrate processing and testing. So we cover on the methods of concentration. I will cover 3 methods of concentration, but might probably for this session I only cover the first concentration methods that commonly used in industry. Okay, we'll go through this one. Okay, the free latex from the tree is the raw material of the rubber industry. So as you know, free latex come from the Hevea brasiliensis tree. The key manufacturer of consistently high quality latex concentrate is careful process control and the maintenance of very clean equipment. Again and again, I will always say that the quality is strongly dependent on 2 main parameters. The first one is the process control itself. Okay, the second one is the cleanliness of your equipments and your tools and so on, because the quality reflect from this best practice of handling the latex fields. Again, the tree is tapped in early morning and the free latex is collected and transferred to a large tank. I go through a bit of the PST 104. Previously, I did mention how you collect the free latex, but I go through a bit fast on this. Ammonia is added as preservative to inhibit the bacterial growth, which would otherwise bring about spontaneous coagulation. Okay, most of the time we will use the ammonia, except certain cases, certain preservation techniques or preservative we might use for different types of application and different types of final products. So the purpose of additions of anticoagulant, in this case is ammonia, to avoid or to inhibit the bacterial growth, and the second one, the spontaneous coagulation. So usually you pour the anticoagulant or ammonia immediately during tapping process, or before you tap the tree, you put a little bit of ammonia in the cups, so that when the free latex flow from the groove to the cups, it will maintain its properties as a liquid aqueous solutions. Okay, and then the amounts of ammonia added to this stage is depend on the time between latex collections and the concentration. Okay, so if the stage, the time frame between the latex collection and the concentration process, you need, for example, okay, I take this as illustration. Okay, you tap your rubber tree approximately in Johor area. And then you need to concentrate your latex in a company somewhere around Negeri Sembilan. So along the way, you will collect many fields of rubber fields, latex from rubber field, before you can reach your destination and proceed with the concentration process. Okay, it will take approximately half a day or maybe 1 day. So this long time frame require huge amount of ammonia to prevent it from any bacterial growth or any spontaneous coagulation. So you need to know from time to time how to measure the ammonia content in your field latex before you can proceed for transportation and before the concentration process can take place. So you need to know about that, and don't worry about that, because this code will also covers on how did you measure the amount ammonia content in field latex and concentrated latex, so that you can control the bacterial growth and you can control you prevent the spontaneous coagulation, and finally you control the quality of your concentrated latex and final products. Okay, the longer storage time require larger quantity of ammonia. I did mention that earlier. The level used in normal between 0.1 to 0.6% of ammonia level, and it can be adjusted according to whether high or low ammonia latex is being produced. Here you need to know what product you need to produce, or which industry you will supply your concentrated latex. By knowing this target area or potential buyers for your concentrated latex, you can adjust your amounts of ammonia for the preservation techniques. Okay, before the concentration of latex is carried out, the latex is tested for ammonia content. This I mentioned earlier, how you measure ammonia in a preserved latex. Okay, preserved field latex. Okay, and then the rubber content, the RC, and the volatile fatty acids number. Volatile fatty acids number reflecting the bacteria activity during the storage or transportation itself. Okay, the smaller the number of VFA is the better for latex concentration process. Rubber content should be between 25 to 35% by weights. Okay. In field latex, the amounts of the RC or the percentage of the RC of field latex is varied. It depends. Earlier, I did mention for last semester, if you can recall, it depends strongly on the genetics of your rubber tree itself, the soil, the what we call the weather, and the fertilizer that you use. So the percentage of the RC that produced from field to field is different. Same goes to the RC of produced from individual rubber tree is also different. So you will have variations of the RC, but approximately it should be around 25 to 35%. But what happens if the RC below 25%? Okay. In this case, I think I will cover this later on, but just a quick precaution I want to mention about this. Okay, if the RC below 25%, usually what happens, we will not proceed with the latex concentration process, because if it is below 25, usually it's very hard to achieve at least 60% of the RC, because latex concentration process usually we try to achieve at least the minimum of 60% of the RC. So you know what happened. So what happened to the latex below than 25% RC? So later on I will inform you. We will cover what we use latex with low DRC numbers. Okay, the VFA is an indication of the degree of preservation of latex. It measures the quantity of volatile fatty acid present in the latex. I think you will cover this VFA on your third weeks of your practicals. So you will measure the VFA numbers, and the VFA number should be approximately around 0.01 to 0.03. In free latex means that latex is well preserved. Okay, so if the number around 0.01 to 0.03, your latex is safe to be proceed with latex concentration process, or else you need to do something. You need to measure it again, so that you might want to separate your latex, which is having higher VFA number and lower VFA number. Don't mix it together, because usually the higher VFA number will reflect on the bacterial activity, and eventually it will affect in the manufacturing process, and especially during the concentration process, it might what we call that, initiate the coagulation process. The higher value of VFA number, I mentioned this earlier, indicates that the latex is not well preserved and will not be used for concentration process. Again, what you do with the higher VFA numbers of latex, usually we convert it, we just coagulate it by adding acidic solutions, okay, so that you can have a dry rubber, and then you produce different types of product using dry rubbers. Okay, this is the concentration of an latex. What we try to achieve here, usually the latex concentrate, the free latex that you tap from the tree contain approximately 30% of DRC, 25 to 30% of DRC, and the rest of it is around 65 to 70% is water that contain in serum, B serum and C serum itself. So by using the concentration process, you will try to achieve latex concentrate of 60% DRC, which is higher, contains much more rubber. So some of the technique may produce higher than 60%, which is good. Okay, we will cover three methods of concentration of NR latex. Later on, I will mention, I will highlight again which method can produce slightly higher DRC content as compared to the rest two of the methods. The standard NR latex concentrate are categorized according to the methods of concentration and preservation. Latex concentrate are commercially produced in Malaysia by the following process. The first one is centrifugation, and then we have creaming process, and the final one is evaporation process. And in our industry, most of latex concentrate produced in our industry come from the centrifugation process. We also have a centrifuge machine, alpha lava centrifuge machine in our lab, and hopefully when this pandemic is over, we can have practical skill by conducting that what I mentioned, the centrifugation machines itself. So usually this is one of your practical that you will conduct in campus. Okay. What is centrifugation? Is the most favorite method, and centrifuge latex is used for the majority of latex application. I did mention earlier. Various batches of free latex are blended together to ensure the uniform product, and centrifuge to ensure a uniform product, and centrifuge to give approximately 60% of latex concentrate. Okay. And then latex concentrate and skim latex, which is the byproduct of this process, are produced during the centrifugation process. The skim latex is subsequently converted into dry skim rubber. How did you convert that skim latex to a dry skim rubber? If by pouring acid solution onto a skim rubber, and then you allow it to coagulate, and you will blend together with your dry rubber. Usually, skim latex will be discarded and will not be used for latex dip industry because the content of the RC is slightly lower. Okay, so but you need to bear in mind the skim latex also content of rubber, so you cannot simply throw away your skim rubber into a waste area. Okay. Okay, this is the illustration of latex centrifuge machine. It's okay. You can see this illustration first, and eventually when you come back to campuses, I will show the actual centrifuge machine that we have in our latex labs. Okay, this is a series of centrifuge machine in industry. Usually industry, they will have a multiple centrifuge machine so that they can cope with the latex that they receive from the field, and also to supply good amounts of concentrated latex to manufacturers or industries related to industry. So okay, next. Okay, here is the productions of latex concentrate. So we start with the field latex. It's go to the latex collections and the bulking tanks. I think we did cover again and again about this in PSC 104. And then after you let your you allow your field latex to settle down in the bulking tanks, you will go to the centrifuge machine to produce a concentrated latex. Here, after the concentrated latex is produced, you can add more ammonia for preservation and or secondary preservative for specific applications or specific final product that you want to produce. And it goes to the storage tank before it can allow to transport it to manufacturers or final product manufacturers. Whereas the byproduct, which is skim latex, will go to the deammoniation tower. Here, we will remove significant amounts of ammonia by additions of acids, and it will go to the skim recovery units before it will produce turn into a skim coagulant and finally become a skim rubber. And this skim rubber usually will be supplied to a dry rubber manufacturers or producers so that they can blend with the cup lumps or feed coagulants, feed grades, so that they can produce a final products. Okay, we go with the first techniques of the concentration process, which is the creaming process. In the creaming process, the field latex is treated with fatty acid soaps and the creaming agent, and then we filtered warm at 40 degrees Celsius and then store in a bulk creaming tank. Okay, and after a few weeks, the rubber-rich cream layer will be separated from the serum, and the cream can be run off separately and homogenized to give a concentrated of 66 to 68 of solid content. Here, although the process of creaming is slightly slow because it takes approximately a week, but it can produce significant good amounts of the RC, which is I would say is quite high, which is 66 to 68 of solid content. And how is it possible that a rubber-rich cream layer to be separated? Because I did mention about the densities of the DRC and the water itself, which is the serum itself that contain high amounts of water, so that DRC is, density is slightly lower than water. So by time within a week they will be separated, and you can remove easily your water and your rubber-rich cream layer. And then the cream latex concentrated is favored by latex thread manufacturer because of the concentrations of latex DRC. Sorry, the concentration of DRC is slightly higher, which is 66 to 68. So it will produce a good latex threads. Okay. And then the creaming and centrifuge method is involved the partial removal of non-rubber constituent relative to the rubber content. Okay, so it's not only removing the separating the rubber content itself, but you also involving the removal of non-rubber constituent. The particle size distribution of concentrated concentrate also differ from initial latex free latex because the proportion of the smaller particle is eliminated at the same time. So usually via the centrifuge machine, so that during the process of centrifugation they will separate the DRC, which is the larger particle size and the smaller particle size. The smaller particle size will be collected and it will become the byproduct, which is the skim latex, whereas the bigger particle will become the concentrated latex. That's why it will this process usually separated the smaller and bigger and smaller particle size of the RC. Okay, the centrifuge regarded as types of accelerated cleaning process in which separation is effected by means of centrifugal force rather than gravitational force one. Okay, here it mentions about the process of centrifugations and the creaming process. How they are different because centrifugation force the material to go through each of the discs of the centrifuge machine, so that the time consuming for a centrifugation process slightly shorter than the creaming process. And then the final process of latex concentrate latex concentrate manufacturing ataupun tech method. Okay, it is an evaporation process. Don't worry, I know I go a bit fast about this because next subject I will go through each of the methods more detail in how parameter that will affecting the final products or the final concentrated latex that you produce. Okay, the evaporation process involves the removal of water only. Okay, previously latex, what we call that, centrifuge and the creaming process also remove the what we call that what we call that non-rubber constituent, but for evaporation process only remove the water only. The ratio of non-rubber constituents and the particle size distribution are unaffected because all of the rubber particles will be used in the evaporation process. In the evaporation process, the field latex is normally stabilized with soaps and alkali with preference of ammonium. Water is removed from the latex in thin film evaporators under low pressure and low temperature, so that we don't want to your latex start to dry out and start to coagulate. So usually you use the low pressure and low temperature so that you can assist of removal of water slowly but more effective. Okay. This type of latex concentrate possesses a high solid content, which is 72 or more, and high rubber content, which is 68 or more. Okay, this is one also the high the good technique to produce solid content, which is 72 as compared to the other tools of method, and the rubber contents also significantly high as compared to the centrifugations, but I would say it is a par with a creaming process. Okay, however, the evaporation process slightly faster than the creaming process. The evaporated latex is used for impregnations, casting, adhesive, and for preparing rubberized road surface. That's why they need high latex. The high solid content, which is 72 up to 72%. Okay, before I end off this session, we will continue this chapter 2 later on, but before I end this session, this is the wise words for today. When a man says I cannot, he has made a suggestion to himself. He has weakened his power to accomplishing the wish otherwise would have been accomplished. So whatever you say, whatever you build into your mind and your heart, you say that you can't do something, you can accomplish something that you want to reach, and actually you already demotivate yourself, you weaken yourself, you put less effort on accomplishing it. That's why you will never, or you very rare to reach your achievement itself. So dengan itu saya sudahi sesi ini dengan bacaan umum kita. Sekian. Terima